Now, in the discussion of the flowchart, the order of execution of given function, this is actually very important so that we will know which function to use and how it will be calculated, how it will be executed, so that we will know which functions should be included first and which functions should be included last. Right? So, let me give you a brief intro. This is the only documentation manual. So you can always look up to this whenever you feel like you don't know anything, right? Event functions are a set of built-in units that are mono-variable scripts and options subscribe to by implementing appropriate methods, often referred to as callback. So these are pre-built method inside the mono-variable script that is the base script of all the others that is the base script of all the scripts. So after we skip for class, the script we will be inherit and from that script we will be covering concepts of different constant. The callbacks respond with events and code in the system. So just rendering user input out of the script in live service from creation, activation, from the timing and from the content update, extraction, and the event occurs into invoking associate callback on your script, giving you the opportunity to view and logic and response to the event. So this basically what does is there are predefined functions which define the service and predefined array is on array variable and these functions. This is done by Unity. They have built on top of C# to create the Unity functions. So to the extent that Unity raises the events of all these associated mono-variable callbacks in the field elimination matter order. The order is documented there, important to understand the execution order so that we don't try to use one callback to do there. It depends on other callbacks that are being invoked here. However, there is a line that can callbacks are for events such as chicken by user inputs, which can occur at any number of events. If it concerns just a combination between one of those scripts where the event callbacks are listed along the system. A complete understanding of these events and innovation. So we have script life cycle overview. I want to know what is the diagram we show you the flowchart. The flowchart. And so this actually it's actually a very interesting interview question which this first called in the life cycle. So await is first called, then enable, then reset. So reset is called when a script is attached to not in playable mode. So you can see the scope of the flowchart. The scope of the flowchart below is limited to the built-in event functions that we have described. Finding only mirror script by implementing the effective callbacks, documented in the messages, the mirror script and reference. Some additional internal methods to refer to the subsystem operation event are also consequences. You can see like when addition to built-in functions, the delegates and converted with this exciting so this is very user callback into a function now this function. So reset we have start that is only ever called once for a given script. This is for initialization, right? And you say this for editor, use the editor only, use it. Then comes the famous update, lead update, and fixed update. First, we have fixed update here. Update will happen less than once per 5 units or more than once per not loop unit. So update is basically a function that updates on every unit. On every frame, this function is being run constantly. So if you are having a camera follow step, if camera follow step will be in the update function and it will be called per frame every frame at least once, right? It will be called on every frame at least once. So then we have the internal animation update, state machine update on machine on state machine enter exit versus star and animation event state machine event always on animation. So these are this everything this comes under the animations. This is the internal project engine, this update. So we'll get the internal animation update, testing animation, animation field, function, recipe, and interaction, collision, and wait for fixed update. These are the internal parts of Unity, but it's given with up so that we can know how things work, right? And now this comes under input event. On now, it is an input event inside Unity. Then we have update. We null, we wait for second, we W, we start coding. The core of we have generated this what is now due to resume the institution display during part of the update. Right? So, what is basically supporting is actually a function which is, you can call an application and run it whenever it's needed. So, it's basically for a function to not disturb the internal life cycle of maybe for a game. Let's say some event is supposed to come from a server. So, that will be under a core routine so that the game functions, the normal game functions of that particular game is not interrupted. So that particular function will be, that particular event will be called inside the core routine, right? So this comes under game object, right? So then we have internal animation update, state machine update on state machine, exit, crossing graph, animation events. And these are some different animation events, state machine, either called animation events, crossing animation, or animated period, or create update. I will be telling about the update, update, and update, right? So the basic difference, this is actually the internal Unity part again, but you need to know how this works so that you can know what needs to be done to have a chance to work with it, right? So update, data update and fix update is different in a way. Update is the update is called for frame rate, right? It is called so it is called for frame rate, right? Every frame and this function is called. So now saying this is just a multiplier. Let's say somebody is playing with a 120 FPS model and you are playing with a 60 FPS model, there will be lag in between because the frame rate is reference. To make the game framerate independent, we are introducing something called fixed update. So this fixed update is may happen less than 1 framerate or half framerate, more than one. So you can also define it in the Unity editor. And how often do you want this update to run, or sorry, fixed update to run, so that it can be to make it change it independent, to make things change it independent, and to it's mainly used in multiplayer games to make the game favorite independent, so that multiple users can play with different amount of players, right? So then we have the update function. No, I have covered update. So then we have the late update function, which comes basically after late update. So it is for the follow. We have a camera clip which we follow each of us. We have a player, and the player is running in the update function, and we have a camera. For the camera, that player is so that follow of the camera will be in the late update. So it's a follow-up script of late update, right? Then we have on sequence, on between visible, on render, pre-render, render object, post-render, render image. So all of these comes under rendering, scene rendering, right? Then we have on draw Gizmo. It's only used by working in the editor. It's for Gizmo rendering for debugging purposes. We will be covering that shortly. On GUI is called multiple times per frame rate, right? Per frame update. On GUI is used for GUI rendering. And India has actually been graphical user interface a lot of times, actually many number of times in the session. So we will be discussing about that. Yield wait for end of frame, it's for end of frame. Pausing. An application call is called after the query, where the pause occurs, but issue another frame that you are actually pausing. Right? This is for pausing the application on application is called the application. On disable is called when script is disable the frame. Let's see on disable again what is the script. On enable will be called if it is enabled again, and on disable it will be called if you are in a decommissioning or disabling a particular game object, and then there is on destroy to destroy the particular game. Right. This is the general thing, and I'm gonna tell. This is actually the script flowchart. I will be telling you about each and everything on this figure, and you will be seeing it. So let's see the general principle here first. So I've told you about these things, right? Now we're going to different exploring different components, right? So this is the project window. Every asset that you will have will be there. Actually, very nicely done here. So you can see it. It's very nicely done. We have starting, mod, so you have starting, mod assets, text smash flow. Text smash flow is basically the text material for that particular piece. This is the asset window. Let me do this. these are prefabs. You can search here. These are all models. You can search on models here. Prefabs or materials. We will be discussing shortly how to create these, right? And this is the asset window. We have organized it very nicely, neatly. This is animation, art, audio, modules, right? Prefabs, subject materials, scenes, scriptable objects. Scriptable objects is something which is an advanced concept in Unity. Timeline is also an advanced concept in Unity, right? So we have these options, mod assets. We have assets. We start as an asset, we drag and drop it here in the scene view, and it will be visible, right? So these are different assets. We have text mesh flow for text materials, right? So this is the project window. When we're done with the project window, this is the basic overview. We will be discussing more about this shortly. This is the inspector window. I've already told you about this, right? This is the tag and layer window. We'll be shortly discussing this as well. You add every component here. Right? You create a game object in hierarchy here. Create an empty game object. Create an add component here. Let's say let's add the audio source component here, audio source. And you don't have a clip, right? You search for sound. Here. Music, or you can just drag and drop this particular clip. And now we have the audio source and a clip attached to this. So every functionality in that game object will go through these components, right? So everything inside Unity is a game object. Everything will be done through game objects. And this is the hierarchy window. It's a nicely, neatly organized. You can organize this like this, right? Different segments, further segments, over track, further into different segments. These are prefabs. We will be discussing prefabs shortly. So you create an empty object. You created an empty object. Now you create another empty object. As you can see, it has become, this is the child object, this is the child game object, this is the parent game object. And if I just drag and drop here, it will come out and be in the hierarchy. Now these game objects are independent. No one is the child object, no one is the parent object. But if I drag and drop it here, again, this has become the child object and this has become the parent game object. So this is the parent and child game object relationship. It's very simple, extremely simple. Unity is actually a very complex topic, but if you discuss it like this, it becomes very simple, and it's actually very simple. It's very easy to learn if you know how to learn it and if you know how to simplify these topics. So this is actually the child and parent relationship, right? So if you add a layout group, the layout group, horizontal layout group. Now you can see that this is a vertical layout group, horizontal layout group. The layout groups we will be discussing shortly. Right? And how to create a prefab, right? We were discussing prefab. So prefab is like this. You have this game object, you drag and drop it into the project hierarchy window, and you have a prefab. Now, what is prefab and why do we need to create it? What's the use of it? Why do people ask in interviews like, what is a prefab? Do you know how to make one? So this is actually used because it's very easy to duplicate this project. Like you can duplicate this here, and we have background 1, 2, background 3, background 4, and I can go on and on and on and on. Right? So this is why prefabs are used. As you can see, these trees are actually all prefabs. This has been done. This tree has been done once, and it has been duplicated twice, 4, 5, 6, 7, and on to 19 times, right? And if I go into this, I can actually find a tree here. Now comes the tricky part. If I just update it here, make it red, all of the prefabs will be reflected at the same time. So what prefab does is it actually saves time. You create the game object 1, you do the setting 1, and you duplicate it, and you duplicate it as many times as you want. And not only duplicate it, you can fix it at a simple you can manage things very easily by creating a prefab. As you can see, I am changing color here, and all of the trees are changing color as I change color in one prefab. So the objective or the main benefit of creating a prefab is you change color and everything will change color. Every prefab will change color simultaneously at a simple time. So let's say I had green color, right? Now boss comes to me and says like, make all of these trees brown. Now if I would not have been using prefabs here, I would have to go to this tree, do it brown here, this tree brown, this tree brown, I have to do brown to every tree, right? So this is a very tedious and time-taking process. To simplify development and to simplify the scene creation, we have simplified it by creating prefabs, right? So I have to change it to brown. Okay, I come here, I choose the color here, and here we do brown, and we're done. Right? So I've changed tree color in around, let's say how many objects we are. You can count it here, you can shift. You can press shift, click here, and you can count it. It actually comes here, but it's not coming here, maybe because it's an older version of Unity. Or maybe including this. So this is around 35 game objects, right? We changed 35 game objects in a single go. So this actually speeds up development, right? Same goes for this hill. Go here, and now your client or boss is tell you that these mountains don't look good. You change the color. Go here again, change the color, and it reflects in a single. We change it in a single game object, and it will be reflected in every feedback, right? So this is how you do things. This is actually a terrain. This thing, this ground plane is actually a terrain. You can change the color here as well. Make it yellow, make it blue, make it green, or maybe white. Green actually looks good here. I know my color grading schemes are very messy right now. I know I'm actually choosing whatever comes to my mind. This is rock, you can change the color here as well. Make it red. Get a new color. Right. So how do you create these colors? You create materials for these colors, and I will show you that as well. You have art materials, and you have materials, right? So what you right click, create material here, give it a name, let's name it new material, you change the color here, and change. We can drag and drop, right? Drag and drop, and it will change color. You can create multiple materials here, you can delete it. Now you can create more materials and change the color here, right? And you can choose to duplicate it, you can choose to make it metallic. You can see it changing color here, all the properties here, right? Drag it up. You can change it. See, it's being metallic. It means changing color, changing its properties here. The smoothness is yes. You can see the difference, right? So this is how you play with materials. It will have a separate module of its own. Everything will have a separate module of its own. I'm just telling you the brief introduction to it, right? So as we go through, and you can duplicate it. Simply press Command B or Control D in Windows, and you can duplicate it as many times as you want. You can change the color, and you can name it material. You are done creating, and that's how you create these many materials. This is a skybox. We will be discussing skybox shortly. Skybox what do is materials. You drag and drop it, not from here, but from Windows, and then right settings. And you drop the skybox. So where did it go? Maybe select something in the way. So let me see. Here is the right? This skybox. Click the wrong button. Anyway, we will be discussing about it shortly. So this is how you do things, right? This is how you do things, and let me play that game. Play this game for you. This is how you play. This is the play button, and this is the pause button. Right, you start the game from here and we call it here. As you can see, the game has started and they have told us to go. If we maximize it and let's go. Use W because I have a W in my code to run it. D for left, S A for right, and S for back. And you can see this is something we are just creating. It's not part of the project that we are doing. Right? So this is something which we have just done. And it will be out. Also, I can go out, but I have some restrictions. Right? Restrictions have been completed. There's a timer running. So we give it over now. We run after the event. This is basic value. I will be telling you about this value. Let's clear again. And you can press start to these options. We have these options. Name. Select all the checkpoints. You have to go to checkpoints. These are the checkpoints. Go through this. We're done with this checkpoint and it's vanished. If you can see it vanished. This is actually kind of a bug that we will be working on. So I got out. I got out and now I can remember. I can remember also I'm supposed to collect those checkpoints. I did not have this really wandering here. So we have this one more road. Let's see. Follow this road and see where it goes. But you get the point, right? This is a 3D environment and you play with it. So this is actually a road which is running out there and you're going out because the timer is going up, right? So you are out of time. 22 minutes and time out and remove. Right? So we go to the menu again. We have not named our game yet. We have controls here to be clear. Play. Start. Here are the basic right. This was the environment and that's how we play. We created in the same view and we played in the game. Right. Let's get out again. Then we can choose to drop our character somewhere else as well. Let me show you that. Here, idle, right? I want the whole card suspension to go up. Let me do the cards. Yeah, card. We have card class classic. Now you can see we are in layer and shift it here on this new and shift it here to this new spectrum. Shift it here and put it on the plane. you can see this camera is going forward. This is camera, and this follow this part which we have added the following script in the upload folder. Right, we have that. And also we don't have checkpoints now. We will be wondering in this landscape. We go up, turn around, and you can see the whole landscape from here on your right. Right. So as you can see that those are the checkpoints, those are the platform that we were supposed to follow, but we are out of that platform now. We are wandering here. We could new objects we just wow, creator again, and you can set it to look at the points here, and you're out of time again. It will go down in a while. And again over. Now all of these game objects have scripts attached to it as components. So all of these scripts has been attached to them as components. We can see that, right? Let me open the player. You can see these are the components. We have Rigidbody attached to it. Script, player. We have around 5 scripts attached to this game object. 1, 2, 3, 4, 5, 6 scripts attached to this game object, which is the card player, which is the player. This string player, right? And we can change the color of this player as well. You can just select the player here, player item, and change this color and bring it red. Red looks nice. Then change the color of the this color as well. Make it red. So that's how materials work, right? Now we have a different set of environment, completely different set of environment, right? So this is how materials work. This is skybox. We are talking about it a while ago. Show you the results. So we have skybox here. Click on this. Now you will see that this environment will get changed in a while because we are changing the skybox here. Now you can see that this is being changed because we are changing it here. We are changing it here, and this material. So skybox we don't want. This is the default skybox which comes immediately. You create a new project and this will be the default skybox. But because this is not a default project, this is a pre-built project, we are using this skybox. And skybox is nothing but a material. You can customize it as and when you want it. You change the properties here, make it red, make it white, make it black, make it black looks nice, I guess. Right? And you can change the coordinates here. So this is how you create a skybox and use it. Right? So now we have flag, surrounding, and we have a sun. So it looks like we have night. Also, we have done it like this. Light it a little. And you can see shadows, right? These are the shadows which maybe is actually calculated. These are the shadows which maybe are actually calculated from this light source. So this is the light source. Some of the light source. So do that. The light source, and we can see directional light. We will change it to different colors. Green, yellow, you can see the game view changing here, right? Okay, black, green, reddish, purplish. You can see the light effects changing throughout the game, right? Let me show you the selected right? Black. You can see the directional lights, right? And if I make it green, the shadows don't appear, right? But if I make it white, shadows appear. They do appear, right? You can see the black shadows here. So this is because there is a light source here and there are game objects here. The shadows being calculated in a way like similar to real world, right? Because the light source is here and the game objects here and the create a shadow here. Right? So this is how basics of directional lights are. We will be exploring more into camera views and everything. So this is the end of this module. So now you can see that this is a 3D space, right? And these colors are actually a thing called skybox. You can navigate through the 3D space using W. If you go forward with W, backwards with S, right, and here you go left, right. If you want to go far, then you can press shift as well, and you can go faster, right. So this is what basically you have to do here. I will show you this. And this is actually the canvas. This thing is called the canvas. This thing is called the canvas. It's actually you see here. Maybe there are two windows. I will tell you everything. What each thing is. So this is the canvas. You must see the environment here. So this is the main window where every addition will be done, every detailing will be done. this is the VM window where the you know the user interface, how it will look like, it will be shown. This is what the user will see. This is the game window, this is the camera that is following it. So this is what user will see. This is the same view where user will see what kind of this is for us to design the user interface, how we design it. We can edit it, we can change areas and in it there are different kinds of options available here, right? So this is a general overview of what we can do. And scale it by 5, scale it 5, then go further, right? This is where you do the user edition. This is how you edit the user space. This is the scenery. This is the inspector. This is a prefab. I will tell you what prefabs are. Right. So this is an inspector. This is the transform window. This is for position. If you look at the X position here, this right, it's changing and I'm changing it in the same window. Right? Red view is on to change it. If you go here, it will also change. If you go here, right? So these are 3 axes where your positioning of this axis will determine the position there. And you can also change it there and the position will be changed according to the response. According to this transform. The ground plane, the simulation drone, the colliders, we'll be talking about everything, this is the material, we'll be talking about these things in a brief moment of time. This is the account where you signed up for your ID, and this is a cloud window, this is UGS, which is your payment services. Collab in case you need to do some collab with anyone, right? This is layering, so every game object goes through layering. This is a concept which you will understand shortly, right? And this is the layout window. You can use tools by P. Sorry, crashed. This is the 2x3 window, right? And this is the 4-split window. So basically, this is for different kind of layout. Right? This is a build layout. This focus more on builds. This is the default layout. This is the tall layout. This is the height layout. For different types of layout, you can change it. You can also save these layouts. You create your own layout, save it, and revert it back. Right? You're going to use the 4-split window. Kind of very similar for us. You can have 4 split windows. You can have 4 windows of scenes, right? This is front view. This is another, this is the top view, this is the left view, and this is the cross section view, this is the right view. So this is the scene window. This is the 4-split, and you can edit it accordingly and change it by your own preferences. So you can play around where you will have game. Better project for us hierarchy is the main thing in a game which has all of these fields. We will be talking about it shortly. These are game objects. Everything in Unity is a game object, and every functionality is attached to that game object. Every script is attached to that game object through scripts, right? Components. Everything is a component in Unity. Every script is a component in Unity, right? So this is how Unity works, and we will be talking about these things shortly. I'm going to tell you what a prefab is. Prefab is something which you create. This background music is a game object which you have created, right? So this audio is the component we added to here. Component audio source, right? Audio source editor. We added here, and then we change it. We'll be exploring more and going into the game. So we'll be exploring this many first. So this is display. We have some different camera displays for different displays for different camera. When we have ratios, we start is actually this ratios are let me show you. So please focus. It will align with as we change this display resolution. And type mode is fixed. It does not affect the overall ratio, right? You see this million view, right? So this is the game music version. 16 16 is really start the issue. 69 found this. You can still get that from here. The next towards in the back. And then we are like custom dimension kind of important. You can do it yourself as well. You can do this, add a label, add two selection with two and resolution, right? So create this energy on resolution. You will click on this and it will maximize and I will show you that in a short. So you got this, right? This is how you post it on different devices. And you can actually add simulators here as well. I will show you that as well in a while. So let's first play. Click maximize and play. I play. We'll end it. Right? And it has rendered and it has maximized and play. Right? Now, I have only muted this virtually. So the mute audio here. We will mute the system audio. Let's say then the audio from here. And if it's all the statistics here, okay. Audio transmitted level audio level is minus 40.088 minus 74.8 dB Hz. Flipping of video version, DSP load, DSP load. Right, you can see the graphic. The computer has in 3 seconds. We are not saving any performance for battery because we are not using battery much, but you can see that it's coming up, right? And this is the statistics we are using 2280 90 into 1450. The minimum resolution that we just said, right? And then you can see the text password, shadow casters, and everything, right? Animations are being played right now, and you can see the statistics, right? You can see the statistics that will change. It doesn't play again on every screen. If the battery we are not giving anything by battery, but now we will right? Right? That was because actually we were using different and you can see that the degree is increased in one time. And you can also break it, you can break the slides, you can make the standard. Right? So this is the overview of how that performs. And then we have business, which is like declining. Everything is giving us like code as well. We will be going into this shortly. Right. And let me tell you about scene view now. So I'm just explaining the editor right now because this editor also feels very overwhelming for people who are not who have no idea of maybe this editor feels so overwhelming. And so now this is the editor part. Now this is shaded. So now you can see the actual vertexes of the actual the real triangle to polynomial terms. This is how these triangles create everything inside Unity. You can see this here, you can see this here. These are also these also have triangles. You can see that, right? These are triangles, and these triangles make everything around you, and the lesser these triangles are, the more performance optimized your game is. So I will tell you how that works. So basically, Unity renders all of these triangles in runtime when we call it, when we run the game in runtime. So these triangles are called, these triangles are actually rendered, and the lesser these triangles are, the lesser the cost of rendering is, right? Let's say we have 15 triangles. So this is how this rendering is done inside Unity. This is the wireframe, and I will be telling you how you can optimize further by reducing these triangle vertices. This is actually just to show you what you can do, right? And this is the shadow back, right? Now you can say, now you can see the environment, right? In shadow, I will tell you the difference. In shadow, you can see the models and not the wireframes. In wireframes, you can only see wireframes, and in shadow wireframes, you can see shadows plus the wireframes. Right? You can see the wireframe of this mountain along with the materials and texture it is rendering along with it, right? So this is how you manage the scene view. Then we have shadow cascades, we have different kinds of render parts, alpha channels, overdraw. So these are many types. There are many types of options in scene view. It's tight mask, min mask is something different. The deferred, the starter smoothness, normal, right? And then change it to shadow again because we have a lot of options. Some of them are shadow for various purposes. And then you can toggle it into a 2D game here. Although it's not a 2D game, but you need to know how it works. So you toggle it and it turns into a from 2D turns into a 2D game. And this is a 2D game and this is a 3D game. In Unity, by default, everything is 3D. You just toggle it from here to create it a 2D game, right? If anyone tells you what is how is Unity different to the games, it's nothing but there are some components and some rigid bodies are 2D. Everything is similar to the 3D angle, and this is the lighting option. You can turn on the lights or the knob. Then goes for sounds, toggle audio on and off. Then goes for skybox. Then goes for skybox, software, language materials, post processing, particle system, different kinds of materials. So I can also tell you these lines. I don't think it's visible right now, but actually there. Yeah. So you can see the grids now. I think it's visible. I might have to turn the grid in the color white, but I think it's visible. These are the grids. As you go along with these grids, they will expand. So you go out and this triangle will form one. Right, and you go more, it will deform, and then you go zoom again and it will deform again. So this is how these grid works, right? And then you can take the going to show it more clearly, right? Right, now it's going to. Then we have this in the component digital panels and shows screen we have the coverage data. We have gizmos and screen camera, how we want to render the screen. Review and everything comes under this. And so in this module we will be discovering the rest of the features. So we are talking about statistics and gizmos, right? Let me show you the 3D environment again. We had a conversation about skyboxes, right? So this is the landscape that we have right now, right? I'm gonna give you a quick brief about hierarchy window. So what happens is we have a game manager. Game manager is actually a singleton reference, so there can be only one game manager throughout the game scene. So we have game HUD. HUD is actually display message, heads over display. It stands for heads over display, and we have a race countdown canvas. And canvas is basically this particular piece. This is a canvas, right? This thing is a canvas. This is the canvas. Right? We need to select it and make it 2D. This is the canvas. We have it. So this select it's not here. So this is the canvas. This is the heads over display. This is the race countdown. This is race feedback, and use less canvas so that the rendering time will be different. The more canvas you have, the more time your game will take to render. Right. So this is directional line. We talked about it. Mist sun. Right. And additional tracks. This is actually all three tracks. Same that we showed you. So mostly you will see that levels are created using prefabs very easily and very quickly. Most 3D levels are designed using prefabs, so because it's very fast and efficient to build it that way, right? So we have this environment and object development, checkpoints, and different kind of game objects attached to it, right? So we'll be talking about scripting in a while. And Sin Machine is actually, it changes your viewpoint. Sin Machine is actually a beautiful concept in Unity. I will show you that in a while. And then we have a camera follow script, right? You know, not my camera, and we see player here. We have the player here. Yeah. Right. So we can see the player now, and as we move, you can see that the camera is following. Right. So this is the player. This has the audio mute button, and as I move forward, you can see that the camera is following me and it's changing its direction according to me. Right. You can see the camera rotating. I go this way, and you can see the camera is following me, and I went out of the scene view. We go again, but you can see the custom is still changing, right? The camera view is still changing, and also I'm out, so I have to switch it here. Here I am. This is the camera that is following me, and this is me. Right? Move out a little. So you can see that the camera is following as and when I go forward and backwards. So this is a camera follow script which is being attached to this. So if we see, if you click on it, again, if you see and click on it, you can see there is a camera follow script here. And post processing layer. and field view as well. So this is how Unity works. Like this is the camera that we are following, that is following us, right? And this is a still machine camera. This is actually a concept in Unity. You can change the camera view according to your your style, or the way you want it as a machine image. This is actually done by all by Unity. You don't have to code it, but you can see that it's so ridiculously simple now, right? If you see it for the first time, if you see this map for the first time, you will think like it's very overwhelming, right? But if you see, it's not that overwhelming. You can very easily navigate through it, and these are some options which you use to, this toolbar is used to go up and here. This is for moving around. This is to select a particular game object. Right. This is to rotate a game object. This is to scale it up. You see the scale changing in the inspector window in the right here. And you can change it from here as well. Do it. You can change it from here. Rotate it. I'm rotating it right now. Right. Change the scale and the positions as well. I can use it to change the position from here as well. If I'm not doing it through this, I can do it through this. Right? Scale it up, and this is usually for to expand it like this. This and this and this and this. This is basically a scale component in a different way. And this you have everything. This is the right transform tool. You can move, rotate, or scale object. It has everything in it in a one scale, right? So this is the hand tool. This is the move tool. This is the rotate tool. This is the scale tool. The transform tool, and this is the all-in-one tool, right? And you can create your own custom tools as well. So center and pivot. What is pivot and center? Right? Pivot is actually a point. Let me show you. So right now we are in the center of the game object, right? And if I go to pivot, the pivot point is this. Pivot is actually it's actually where the game object will start. So this is the pivot point of the game object. And local and global means global is the global coordinates of the gaming system. Local is specific to a game object, right? And collab is basically for a teamwork. Basically for teamwork purposes, collab is there. And then we have Unity Cloud, UGS services. UGS services has a lot to offer now. It was very decent few years back, but it has a lot to offer now. Right. Like these are layers. I can on and off some of these layers, and you will see that some things go away. Default, these are in the default layer, right? This is the transparent VFX. This is ignore raycast water. UI went away. If you can see here, UI went away, right? Because I did that particular layer. Post processing ground went away, and I like
on the layer ground. So I am basically hiding this. This is show and hide for layers. These are in different layers, so I can hide it. I can re-enable it from here. Track is visible, crash point is visible. So you are actually disabling the layer view, but in the final build, these will be still there. So you can hide and show here the layers, but in the final game object, if the game object is enabled, it will be included. Right? You can lock layers as well. I can lock the environment. I can lock roads, right? Ground, lock it. So now it won't. I cannot move it. Right? So these are some of the basic, introduction of every. I think we have covered all of the tabs here, right? I think we have covered all of the tabs. So this is the build and run tab, build settings, PC, Mac, Android, WebGL, tvOS, PS4, iOS, PS5, iOS, Xbox One. So let's make a build. I will tell you how to make a build of this. So if I make a Linux build, Mac build of this, I'm going to click build and run. I will name it test build 1. Right? And so it will start building now. As you can see, it's still loading and it will load in a while. It might take a while. Still loading. So we are actually stuck here. I'm gonna stop it for a while. So here we are again. Let's go to the discussion. So this is a single project again. We will be going into the lesson shortly. So as you can see, that actually style was as we have discussed before. It was actually style was not doing anything that are doing everywhere. These are doing anything. These are in free space that we are working on. Let's explore the free space first. Basically, so this is the game or the map that we have created here. You can duplicate it and make it larger. Then press icon and we will be doing this and exploring a lot of other things. Right? So first we will go into this game. There is this new pot and it has a direction. Right? And the
Anything comes in area will be automatically sorted, right? So these are people not really correct people not right. When start from here, and start from here, right? This is our player, and we don't have a physical person here. It's just the player and primary, right? And there's a weapon component. I will show you when it's here. And I will show you when it's here. So this is the when you come out and you shoot this thing and go down and shoot the final enemy. Right? Let's see how we do it. You can see that there are the things that is there here. This part here. Let's see how it is. You can see that the ceiling of the transition darkly. And here we go. And we call dark spirit. And we are there. There is a video in another video. Open space, right? And you can jump on it. And also it's a little up. So you won't be able to walk on it. So navigating this scenario. And then if we fall down, we are there. We are doing it. Right? So this is where we are. We have a rigid body attack. That's why we are going down, and there's a just attached that if we go down below a certain surface, we will kill when we start. And this is the scenario here again. This is help of different strategies related to our health. So we have to first primary and the shooter. Here it again. All objectives are completed and we bomb. Right? So this is the game that is just a simple game, simple FPS game. So this is a first person controller. This game is meant to show you the dynamics of how first person controller is. Let me show you how it is. This working. You can see that it is and it is working. It's actually showing that if we are here, right? It should not be this way. Actually, it should not be this way. If you are creating an optimized game, it should not be this way that maybe for game is first loaded and we are not there. Right? We are just loading here and we are not inside this mainframe here. So if we are not in this mainframe, we want that this should not be rendered. This part should not be rendered because we are right now here. And this part is out of our size, so this part should not be rendered. A technique or optimization may use what is called as a clean column. So this part is actually wrong. It is not render and unless you see that. Right? Let's go again. You will see we have entered the directory. This is good. Then we will moving around. You can see it, because it's a small around it. And you can see the here. We are here, right? Then you can see the camera moving. Right? There is no person here, like the previous one, there was a character and the camera was following that character, right? It was on a heads-up controller. It was following the character, the camera was in a follower. But in the camera is itself the player, right? We have a glass solution here, which is created and the starting right? You can see the working camera. You can see the camera, it's actually regarding stuff. Right? So this is how this thing works. Now I'm going to show you how this animation is being done. This animation this is an enemy alert, and this is a free fire actually. Inside this free fire we also have another free fire which is created. You can change it, you can customize it there anyway. So how it can move is we have a business treasurer and a bigger dashboard. So all of them has three colliders, box colliders. This base has a box collider so that it can stay on the ground. But without a collider, it won't stay on the ground. I will be telling you what a collider is most of the time. And I'm just giving you a brief introduction about these things because it is very overwhelming in a single day or in a single course. I'm giving you an overview step by step, like how it works and what it is. And then I'm gonna explain it there and then you can understand it better. I will give you a brief, then I will make a in-depth tutorial or video on that. So that model will help you. You can see that it is separate actually. Everything is separate. This favorite robot is separate. We have an animator controller here. We will be telling you about animation stuff. We have this is the animator controller and this is the idle state. We have an animation attached to it, animation flip. Then we have attached this is triggered when you come into contact with the directory. Then we have the attach loop and the attach. It is mostly the idle state would be working. Right? It's mostly the idle state that we see. So after entry going to the idle state, we will draw the idle state. So we are going. So this is the idle state. Right? This is the idle state. It is forming here and here. This is the idle state which is being controlled by the animator controller. Right? And once we come in contact with it, it will switch. I will tell you the animator. Here you can see this is right here. So we are in the idle state right now. And the animator controller is doing this. After we go in contact with this will be actually be changing the position. Yes. So now I think the overall overview is finished. To get a basic idea of what this thing is, right? And how things work. So I'm gonna tell you about directional light I already covered. I'm going to tell you about how these things work. So these things have a box collider, the C collider. And I'm going to show you an example that you see here. Right. So, so we have a collider here. And this is mesh collider, right? We create an object. Let's create a cube. You see, the cube is actually standing there, not doing anything. It's stuck there. Right? I have this. You can see the cube here, standing there. And it's not doing anything because it does not have Rigidbody attached to it. It does not create a 3D figure. It's just a game object that is stuck in time. If we attach Rigidbody to this, so there are two Rigidbodies, one is for 2D perspective and second is for the 3D. And you will see that it falls down. Falls down and goes through this it's still there. It's there, right? So now we have attached Rigidbody to it. It has a certain physics properties attached to it. Let's say we suppose this mesh collider. Now you will see that this actually goes to the surface, right? Because there is no collider. If we go through it, we will also pass through it. Right? So this is the purpose of colliders. Colliders actually, it gives it a physics component, it, it gives a, you can say that it gives a surface to it. Gives a surface to it. Let's say your laptop it does not have a slider attached to it, so your hand will pass through it. But if it has a slider attached to it, it your hand won't pass through it. In the terms of unity game development, terms of unity game development, this is how colliders work. And just because it has a rigid body attached to it, you don't have to attach box collider because it is already there. Remove the box collider here and play it again. It will pass. Right. But this surface has a mesh collider attached. Right. And this surface does not have a mesh collider attached. So it will pass through. Because there is no colliding happening, there is no collision happening. But if we attach a collider again here, you will see that it will drop down and it will roll up. It will roll up. So both of the objects can have colliders attached to it so that there is a collision happening. We also have a collider attached to all cells in the player segment. You can see that we have a character controller attached here, a resource, and a lot of components attached to our source, right? So we have these many components attached to it. Right? And the same goes for the main as well. This has actually a collider attached to it, and the key tab which you can create, which will and the bottom of the turret center and the base. The base has a box collider attached to it, actually two box collider attached to it, so that it does not go down. Let's say off it, so it should go down, right? But it will. So you still have some colliders attached. We go again into the enemy storage. And Mesh is actually this is the component responsible for the attack. It will calculate if the enemy is inside the area of this component. If it is inside the component, it will attack, otherwise it will. So this is how we do it. Now let's say the go this standing. Let's say this wall does not surface area collider. The surface collider is right? So when you go down, right? You go down because as a collider to extend that the floor did not have a collider here. Right? But still doesn't go down because it's cycle which is tempering a bit surface. It can go down even now, although the floor is not there. You see it, the floor is actually empty here. Right? These are the nuances of design development. You can see that it's like saying, you know, held by this particular piece, and it does not have a rigid body as well, so it won't go down. Still not going down. Even though the collider is attached to it and there is no surface beyond this, below this, so it is not going down because it does not have a rigid body attached to it. Let's say I have a rigid body and it will go down going to the bottom of this here. It's going down, 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 down. And it will go down till the bottom of the interior engine, right? So this is how colliders work. You will see all of the other colliders, their surfaces. You can see where I have using here. Let me tell you about all of these colliders in a while. Not just right? If you search here collider, you can see that there are different types of colliders. Box collider for a box, for a capsule. For a cube, there is box collider. For a capsule, there is capsule collider. For mesh, there is mesh collider. Sphere collider. Parent is actually ground which we walk on. So this is the parent collider. Time mass collider is not really not for us. There's a beam collider for a car. Right? So these are the different types of colliders, and if you go collider 2D, these are the 2D colliders. Box collider 2D, capsule collider 2D, circle collider 2D, composite collider 2D, custom collider 2D, edge collider, polygon collider, time map collider. Time map is actually a system including events where we create the surface level using time map. So you will be seeing that in the previous example that I will be showing you. So this is a collider work. We have covered collider, Rigidbody so far, right? And if you bring back that going down, that wall going down, let me look back into it. There. double click on a given object, it will focus you to that image. Now, you have this view, you created this view, right? You have this little view. Now, let's add experimental body. If you increase the mass space, it will go down very quickly because the mass is very higher. Let's see that it will go down quickly. Go down. And then you put one zero. Last class, when we have shared where you can see still going line because variable master part. So given property of the game, let me show you again. You have a zero in the rigid body component mass, but it created a mass already. First, anything which has a rigid body attached to it, so the rigid into the charge is 0.5, 0.05, which is equal to 1. The charge will be center of mass, center of gravity. If you don't use gravity, it can go down. Not very long, right? Still have a mass, still have an angular guard, still have the automatic center of mass, but you do not use gravity. That's why it's not go down. Right? So what I'm going to telling you is actually a Boolean expression. So these are the layers like the layer here. So this is all about rigid body and collider. Collider is not good in type of collider. You can edit the collider as well. This is a collider sequence. Click on this edit collider. This is the collider. Now, if you see, our collider was at the corner of the game. This is the corner of the game, and the collider is covering the corner of the game. Then extend the collider will extend. Now the collision will be happening at this point, not at this point. This also does not have a physical render for this thing. No, it does not have a physical space for this thing, but the colliders, the collisions will be happening at this layer. If you drop it on out of space, it's colliding. Collision should be happening. Just show you that. Let's rotate it. bring it up. So we don't have directly if we're going to say just something because we can start now if you don't see it's actually in there. It's actually in there because the reason is happening at the same time. It's actually expect the whole thing. It looks like it's still now you can see it here. It stopped in mid-air because the collisions, the colliders are happening here. The colliders are happening here. Also the two times here, but the collider is here, so it is not. It's in airspace. It will stay there unless and until I edit the collisions and make it as it was before. It has stopped in air. It has stopped it being in air. If I increase the collider, we go down. And if I increase the colliders, it will go to power and the collider. Increase it, we go up, and we stay in that motion. But it is actually falling. This cube actually fell, but because we can see it's not going up because we have used gravity. The table gravity from here will go up without any issue. Use gravity, it will go down and it will stop there. Because it will stop in air because the colliders are here. Okay? The colliders are here, so it will stop in air. Now, if you make it to a certain without the gravity, the secondary gravity, down and going down all the way. Right? It is not stopping here. Therefore, there is still a difference in collider. We did not do it directly, but you can see the effect. It did not stop here. So this is how colliders work. You can experiment with it. So these are basically simple basic tools and you use it to create a very complex structure of environments. I will show you one easy environment. That's how we can create a very complex structure with it. So let us go down. I will be showing you more of these fun details and functions.